0, you will get tan 0 will be 0 and log 0 will be infinite, so it is 0 into infinity form. So either you can convert it as log x upon 1 by tan x or tan x upon 1 by log x. But whenever you deal with such kind of problem in which one function is log and another is some another algebraic or we can say transcendental function, then never write that form by making denominator as a log. Whenever such kind of functions are given, you have to write it in fx upon 1 upon gx such that the function having log, which it must be on a numerator, because we don't know the derivative of 1 upon log, otherwise you will feel somewhat difficulty. So here let us see in this example. I have bring 10 in a denominator as 1 by 10, but we know that the 1 by 10 by using trigonometric formula it will be quote. So it is log x by quote x as x tends to 0. So now you put x is equal to 0, you will get infinity by infinity form. Then again you can easily apply L'Hospital rule. So log x will be 1 by x and cot x will be minus cos x square x. These are the derivatives of log x and cot x. Now again we can simplify it. Then on simplification we will have limit x tends to 0 minus sin square x upon x, and that will again we can use here our standard formula, that is limit x tends to 0 sin x by x is equal to 1, that is equal to minus sin x limit, and that is 0. So finally we will have answer 0. Next sum is limit x tends to 0 1 by x into log 1 plus x. On substituting x is equal to 0, you will again get 1 upon 0 will be infinite, log 1 plus 0, so log 1 will be 0, so we will have 0 into infinity form. Then again we can use it as log 1 plus x upon 1 by 1 upon x, so it is log 1 plus x by x, that will again converted into 0 by 0 form. So you can easily apply L'Hospital. On applying L'Hospital rule, we will get the derivative of log 1 plus x will be 1 upon 1 plus x, and derivative of x will be 1. Now on substituting x is equal to 0, this is not a 0 by 0 form, so we can put x is equal to 0 over here, and we will have answer is 1. So in this way 0 into infinity will work. Now next again I have put here some of the example as an exercise for you. You can try this one. These are some examples that you can work out by using this form with answers. Now next is we have to deal with the next type of indeterminate form, that is infinity minus infinity. So again, if we have two functions which are given in a subtraction, that is fx minus gx at some x tends to a, then if at x tends to a fx approaches infinity and x tends to a, gx is also tends to infinity, then we have to face such kind of situation, that is infinity minus infinity indeterminate form. So for finding this limit for these types of indeterminate form, we have to apply one procedure, that we have to divide numerator and denominator by fx into gx. So let us see the rule, how it works. and what mathematical operation we have to perform to make it either 0 by 0 or infinity by infinity form. L'Hospital rule for 0 infinity minus infinity form. So whenever functions, as I have told you, given in this kind of form, then either you can write it as 1 by fx minus 1 by gx upon 1 upon fx into gx by dividing and multiplying by fx into gx. Then it will be reduces to 0 by 0 as x tends to a, and finally we can apply L'Hospital rule to it. So let us see some of the examples. So example of infinity minus infinity form. First example, limit x tends to pi by 2 sec x minus 10x. Now on substituting x is equal to pi by 2, you will get infinity minus infinity, because sec pi by 2 will be infinite and 10 pi by 2 will be infinite. Then we know that sec x is equal to 1 by cos x and 10x will be sin x upon cos x. So by using trigonometric formula we will have this thing. Then on taking LCM we will have 1 minus sin x upon cos x as x tends to pi by 2. Now on substituting x is equal to pi by 2 we will get 0 by 0 form. So when you get this kind of form, then easily you can apply L'Hospital rule. So by applying L'Hospital rule, the derivative will be 0 of 1 and cos x of sin x, and denominator have minus sin x. There is some mistake. So finally when you substitute a limit, the answer will be 0 because numerator will have cos x. Next example, limit x tends to 0 1 upon x square minus cot square x, which is again when you substitute x is equal to 0 you will get infinity minus infinity form. So further you can simplify cot square x as a cos square x upon sin square x, or rather 1 upon tan square x. So on simplifying you will get this thing. Then again taking LCM we will have tan square x minus x square upon x square into tan square x. So again here you can see that we have a situation as we have seen in the example of the type 0 by 0. There limit x tends to 0 sin square x minus x square upon x square into sin square x. So we do not have applied directly L'Hospital rule, even it is applicable, because as I am going to apply L'Hospital rule directly on such kind of function, then it will be so much lengthy. So here also again we will not apply directly L'Hospital rule, but we can either multiply by some of the power of x and making some standard formula. So as we have done here, as I have multiplied here by x square because my denominator contains tan square x. So on multiplying by x square and dividing by x square we will have such thing. Then again separating the two functions we will have limit x tends to 0 tan square x minus x square upon x raised to the power 4 into limit x tends to 0 x square upon tan square x, but again that will be 1. So remaining thing will be tan square x minus x square upon x raised to the power 4 at x tends to 0. Now on applying L'Hospital rule, as it becomes 0 by 0, the derivative will be 2 tan x into sec square x of tan square x and 2x of x square, and denominator have 4x cube, that is the derivative of x raised to 4. So the next is again it will be 0 by 0 form. So again you have to find the derivative, that is again I have applied here product rule. then again it will be 2 into sec raised to the power 4x plus 4 10 square x into sec square x minus 2 upon 12 x square, which is again 0 by 0 form. So again I have differentiated, because until and unless we have to apply L'Hospital rule until we do not have some finite value of limit. So now at the end I have taken 10x common from the numerator, because denominator contain x, so that will be 1, and now it is free from variable, denominator is free, some finite value. So now as we apply limit on it, because it is not 0 by 0 form, so finally we will have answer as 2 by 3. So in this way it can be calculated. Otherwise, if I will directly apply a L'Hospital rule, then numerator will be larger and larger, and it is somewhat lengthiest for me. Again I have put exercise for it, you can try the example of it. Now the next type is L'Hospital rule for 0 raised to 0, 1 raised to infinity, infinity raised to 0 form. Now the process for evaluating such kind of functions which leads to either 0 raised to 0, 1 raised to infinity, or infinity raised to 0, you have to follow a same procedure, or we can say same method, for all the three kinds of indeterminate form. What is it? Let us see. So whenever we have a function raised to the power function which leads to an indeterminate form, any one of the following type, that is 0 raised to 0, 1 raised to infinity, or infinity raised to 0, then the evaluation of such kind of function can be, evaluation of limit of such kind of functions will be taken as follows. First of all, you have to assume the function by some variable, then taking log on both the sides, then by using the rule of logarithm the power will be in multiplication, that is gx into log x, then apply the limit on both the sides, that is limit x tends to a log y is equal to limit x tends to a g of x into log fx. And suppose right hand side limit will be L, then limit of log y will be L, it's my mistake, it will be log y, and then we have finally the limit of fx raised to the power gx will be e raised to the power something L. So as here we have taken log on both the sides, then after we will have such operations performed. Now let us see the example of the type. First example, limit x tends to pi by 2 10x power cos x. So you can see that on replacing x is equal to 0 in numerator and denominator, you will get 0 by 0 form. So take assume function, then take log, apply limit, then right hand part will have some indeterminate form, here it is 0 into infinity form, then find the, convert it either into 0 by 0 or infinity by infinity form. So here it is infinity by infinity form, then find the derivative of it. On finding derivative you will get this term, then again one power will be cancelled out, then you will have again infinity by infinity form. So again you have to find the derivative will be this, again from numerator and denominator 1 power of 10 and sec will be cancelled out respectively, then finally you will have 1 by 2 sec x at x pi by 2, then which is not infinity by infinity form. So answer will be finally 0. So today we will stop with this. Thank you. Okay.